All right, so I will record this. If you didn't see already, I have some reviews already posted for Boyce students on my YouTube channel. If you go onto the YouTube channel and just search for either Boyce or BO in the videos for your section number, so like 220, 230, and then oftentimes I even created a separate Boyce playlist. And then you could even go back and look at like the Boyce 130, 110. You could look at the Boyce. I don't know if I've done Boyce 240, but if anything that's on there that's Boyce related, there's a lot of overlap, especially the way your classes and the way your questions are asked. They're very consistent. You can use the Allegheny campus information. Their questions are slightly different. They have a couple of ways that they ask questions. Like they don't do this intake question like you guys do with the fluid intake. I believe the heparin protocol is asked just a little bit differently, but you still need to know how to do the same things. And then they are typically given what units they're looking for, meaning like solve for, how many milliliters would you administer? What would you program the infusion pump to in milliliters per hour? So they know that going in. When they ask the question, a lot of your questions are, what would you set the infusion pump to? And you need to know that you need to either set it for drops per minute or milliliters per hour, based off of the context of the question. So what I'm going to do is I'm just going to jump down to what I know is the new thing. And what I'm basing that off of, I'm going to open this up real quick. The blueprint for your dosage calc. So just give me a moment. Let me open this up. So if you ever need a review of the rounding rules, just make sure you check your blueprint. Your blueprint is what tells you, your rounding rules. Even though it says milliliters, technically we can use the rounding rules for anything. It's just that the majority of the time we're using it in context of milliliters. But if you're converting pounds to kilograms, like just a basic conversion, meaning like it just says convert 165 pounds to kilograms, then you would round your answer to the nearest tenth, because I imagine your instructor doesn't want a whole bunch of repeating numbers in a long litany of numbers. They want it to the nearest tenth. If that is different and your instructor has told you different, please follow their instruction. I'm basing this off of what I've been told, and sometimes there's discrepancy. So, all right. So for you guys, you'll see that the 220, 230 test pretty much is the same. There's no real difference between the 220, 230, like whichever section you're registered for. So that's why I always combine the two. But you can see the blueprint. It tells you the types and numbers of questions that you're going to be asked. And then that way you have an idea of the types of questions. So like their first 4 questions are going to be basic, like kind of converting like metric to metric or converting pounds to kilograms. Then you'll have an intake or an output calculation. So your intake question is like, identify the fluids, convert the fluids that are typically in household units like pints, quarts, cups into milliliters, and then get a total. If you look at Allegheny campus, they do a fluid replacement question for this. So it's kind of like a combination of intake output, where they know how much the patient has voided, and then they're told to replace, the fluid. But you can look at that if you want to, but I haven't seen that as part of your test. You've done a lot of these parenteral medications. That, and again, whenever I say it's an assumption. So if you don't know, hopefully you will after today. Like if it says subcutaneous, IV, intramuscular, or subcutaneous, that that's an injectable, and that your units are going to be milliliters, because that's the standard. So if it's telling you to calculate a parenteral medication, that you're looking for milliliters. You're not looking for tablets, capsules. You can't inject milligrams. The milligrams are delivered in a volume. So it's either a volume, milliliters, or capsule or tablet. I think most Boyce students are rock solid on insulin. You got introduced to the IV therapy, which just means you're calculating flow rates, which is you need to know it's either going to be milliliters per hour or drops per minute, depending on what they're asking for. You've seen reconstitution now twice. Remember, it's that funky label where you have to look at the label to see what the actual strength of the medication is. And I'll show you the example. And then I think the thing I said that's new is this heparin bolus and heparin infusion. I think that's the only thing that's new, because if you go up to the 130, you'll see that that's not listed. There's no heparin anything in here. So I'm going to start with those and then show you to do this. And then we'll see, there might be a question about nitroglycerin drip. And if there's not, I have a sample from Allegheny campus that will suffice. All right, so let me switch my share back over here. So this is the only study guide I have for really anyone at Boyce. I don't have, I don't know if you guys get like a packet of study questions or study ideas, or you just get a blueprint and they say have at it. But a former student, I'm assuming she's in like a nurse at this point, Maddie Kessie, she put together this and basically just followed the blueprint and said, starting off with metric and household, 2 questions, and then she just kind of broke it down and made herself a study guide, and then she gave me permission to share it, and then that's what I've been using to help anytime I work with Boyce students, because she did a great job with this. And then there's some tweaks that I'm doing to this. Like I have this listed in your Boyce shared folder for the 220, 230. It might just be called 230. And I renamed it 24 Spring, but it's the same as the original dosage calc. I just renamed it 24 Spring because I'm going to change the numbers as we kind of go along. I'm going to draw on it and things like that, so you have access to what I'm looking at. And so yeah, so someone said, yeah, if you go to the OneDrive shared folder, so your instructor should have sent you a link that said like a link to my YouTube page and then a link to the shared OneDrive folder. If you don't have that link, you can email me and then I'll get it to you, and I'll put my email in the comments. All right. So you need to know these conversions. You should have them pretty much memorized at this point because you've seen them now the last 2 semesters. You remember that they're not going to give them to you. They're not going to tell you, oh, this is what this is. You are expected to know these things. I will say I have yet to see where they've asked you to do pounds to ounces, kilograms to grams, or even meters to centimeters to millimeters. But if you do, then they're listed there. Okay. Just some notes on intake, right? She did a really good job of isolating like juice, water, milk. Talks about ice chips. I haven't seen that as a test question or a missed test question, but it's there. Drinks, Jello is predominantly water. Broths, ice cream is technically milk. Now, the reason you don't do fruit cocktail or chunky soup is because the majority of it is food, not liquid. So if it was tomato soup, you could say that's predominantly liquid. Popsicle, sorbet, anything that can melt and be drinking, did it? Yeah, you know that word. I do not have any more practice questions. Only because I don't have I don't have anything that I've ever received that I could build practice questions from. So I just use Maddie's, and then what I do is, as we're going through some of these, I just tweak the questions. That way you are getting a different question. Yeah, you should be good with the ones that are listed here. So let me go to the heparin protocol, since that's the new thing for this semester. This is the reconstitution question. So you're gonna, I have a folder in the shared OneDrive that says reconstitution labels. You can look at some examples of what some of these might look like. So you might see ANSEF, you might see Kefzol, You might see a cephalexin, Pfizer pen. There's a couple of different variations that you might see that are going to be the thing you have to pay attention to is looking for in the instructions to find out your milligrams per milliliter. And then it's very transparent. It tells you specifically, like here, it tells you it's 225 milligrams per milliliter. It's right in the label. You just have to know to look for it in the label, and you don't use that 500 milligrams, but we'll come back to that if we need to. All right. So let me get to this heparin question. So if you go on to and look at like Allegheny campus, the way that they do their question is just a little bit different. They actually show the entire heparin protocol, which means there's a lot of like extra steps that are just not necessary. You don't need to know those extra steps. They're just listed in what is known as the protocol. So I have a strong feeling that if you get asked a heparin protocol question, it's probably going to look more like this, where they're telling you, like they give you an order, they're giving you the available, and then they're asking you what to do based off of that. So what I'm going to do is I'm going to change this question up a little bit, and I'm going to just change the patient's weight, and then we're going to kind of solve this together. So I'm going to say this is a 178-pound individual. So that's really the only thing you can change in the weight-based heparin protocol is the patient's weight. Now, what I know from Allegheny campus is that you will get, this will be one question, but there'll be two sub questions associated with it. It'll ask you to calculate the bolus, and then it'll ask you to calculate the drip. Okay, so there'll be two things. Now, in this example, they give you the units associated with what you're looking for. You just have to remember that in a bolus is an injection, so that would just be milliliters. And if it is asking for a flow rate, then it's asking for milliliters per hour. And then if you're ever wondering, like, well, how do I know when to calculate for drops? They'll tell you that they'll give you a drop factor. They'll say something about microtubing. They are usually very explicit in explaining, like, hey, this is what you need as far as that's all concerned. And like I said, Maddie did a good job of giving some examples of that. All right. So if this is your first time seeing this and you haven't, tried it, I just want you to know, like, the protocol, if we're talking about a weight-based heparin protocol, it's standard. The standard protocol, or the order, if you will. So I'm going to rewrite this as the order. The order is to bolus the patient with 80 units per kilogram, and then to start them on a drip at 18 units per kilogram per hour. So that's your order. And then when it tells you this is actually your available. So if we're talking about weight-based heparin protocol, it's the standard. It's the available and it's the order. And then the only thing that really changes with this question is the patient's weight. Okay. Now, previously I have said, take the patient's weight, convert it to kilograms, round to the nearest tenth, solve for the bolus, solve for the milliliters per hour, and then I would tell you that would give you, and then you end up rounding again. So I had a couple students ask me about that. Technically, you shouldn't be rounding again. And I'll show you how to set this up. And then you can just plug it into your calculator. And then once you get the routine of it, then it should be straightforward. So let's start with the bolus question, or bolus part. And then we'll go into the flow rate part. So the first thing I need to do is I need to find out what the patient's weight is in kilograms. So I'm just going to take out my calculator. I'm going to take 178, divide by 2.2, and it's going to give me 80.9090 repeating. Okay, thank you for putting that in there. Okay, so we're going to say it's 80.9 kg. So we rounded, and I'll show you how Whether you do it, whether you round it or not, we can still get to the same answer. Okay. So this just helps out when I'm writing this out. Okay. And then I'll show you how I would do it in reality. So if I'm starting with the patient's weight in kilograms, I'm going to take the 80.9, and then I'm going to multiply by, since we're calculating the bolus, I'm going to follow what it says here. It says bolus with 80 units. So 80 units per kilogram. That's supposed to be kilogram. So that crosses out. I'm going to take that 80.9 times 80, and I'm going to get 6,472 units. Now I don't want units, I want milliliters. And then in the event that you're doing this, you don't want units, or it doesn't tell you, you don't want units for the bolus, you want milliliters. And the way you would also know that is because it tells you that it has a bolus dosage strength of 1,000 units per milliliter. So that tells you that you're going to be doing some sort of conversion because they want to know how many milliliters to administer, just in case it doesn't tell you. I think it will, but so my next conversion is to take my 1,000 units, 1 milliliter, and I'm going to get 6.472 milliliters. And I'm going to go ahead and round that to 6.5 milliliters. Okay. Now, I want to show you real quick. I'm going to open up my calculator and show you, like, let's say you have a problem with, and I'll come right back to this. So if you're like, wait, go back to it, I'm going to come right back to it. So if you have a concern about, you want to just round the one time, I just want you to see that it should come out to the same answer. So what I'm going to do is I'm going to take 178. I'm going to divide by 2.2. I'm going to hit equals, and I'm just going to leave that number there. Then I'm going to multiply by 80. Then I'm going to divide by 1,000. So I'm just following the steps that we just did. The only thing I'm doing differently is I didn't change, or I didn't use the rounded weight. Notice that we still get the 6.472, and it just keeps repeating, but we're still going to round to the nearest tenth, right? So my answer is still 6.5. All right, let's go back here. All right. Any questions on how I got to the 6.5 milliliters? I see that someone's been watching my videos and just following with the flow, which is perfect. If you got the same answers I got, then hopefully we're all doing it the right way. All right, then let's do the flow rate real quick. So same patient, 80.9 kilograms. Then my new order, it says to start a drip at 18 units per kilogram per hour. So I'm going to multiply my patient weight in kilograms by the 18 units kilogram hour. So 80.9 times 18 gives me 1,456.2. And that's units per hour. And then with heparin, and then you're gonna see other examples of this with where it says units per hour, and then it says it'll say, like, for heparin infusion, it'll say the same thing for insulin. So if you have to convert insulin units per hour to milliliters per hour, we're going to do the exact same step in that I'm going to look at what I have available, and I'm not going to use the bolus because we're not calculating a bolus. I'm going to look at this IV, right? 250 milliliter half normal saline that has 25,000 units of heparin in it. So If you ever get stuck, what am I trying to get rid of? Units. What do I want? Milliliters. 250, 25,000. And you're going to get 14.562. And you're going to go ahead and round that to 14.6 mil per hour. Now, sometimes students will get hung up on, well, you can't program that in the infusion pump. I've seen that in the, in the hospital, or I've seen that you can't set it to a decimal setting. That might be correct. But from what I understand, based off of the blueprint, you're supposed to round these things to the nearest 10th. So in reality, you might only be able to set this to 15 milliliters. And so, or 14, or 10. I don't know what it is in reality. All I know is based off of the math, that's how you would express your answer. So again, the only thing that would really change on this is the patient's weight. And then I told my Allegheny students on Tuesday, there's a shorthand way. So if you ever just want to plug this in and double check your answers, because I know they're gonna ask you to show your work. You're just gonna take the patient's weight in kilograms. And then for the bolus, you're timesing by 80, dividing by 1,000. If it's the weight-based heparin protocol, that's the flow that you're doing. If we're doing the IV, I'm going to take the patient's weight, multiply by 18, and I'm going to divide by 100. Now, the reason I do that is because the 250 over 25,000 is the same thing as 1 over 100. So I know that from doing this over the years, that's the relationship. So if you don't feel comfortable doing it that way, you don't have to. I'm not asking. I'm just giving you a shortcut way. If you're ever like, I just want to check my work real quick. Am I doing this right? Patient's weight in kilograms times 18 divided by 100 will give you the flow rate for weight-based heparin protocol. Patient's weight in kilograms times 80 divided by 1,000 will give you the patient's weight, or give you the bolus dose in milliliters for the weight-based heparin protocol. The other thing is you always have to pay attention, like if they change the available, which I doubt they will, or if they change your bolus and your drip rate, then you might have to make some changes. And I think they do that. I think Maddie gave some examples of those. Like this one here. You're starting at 18, patient weighs 75. The heparin infusion comes in a 500 mil. So this is a different variation. And then you would just calculate the ml per hour based off of the new information. So like I said, let me give this to you because I know you've probably worked on this. Let's just say let's just make this a 100K patient. Okay. So 500 mil, 25,000 units. Go ahead and solve for that question. Just type it into the chat. Once you get it, you can send it as a direct message if you don't want to share your answer. But if you want to share it to everyone, go ahead. And then I'll let you know if I get the same thing. It'd be good practice. Don't forget your units. All right, looks like the answers are coming in. If you answered, I gave you a thumbs up. And Ashley was the public one and Kathleen, so you can see what the answer is. If you come back to this, it'll be good practice. And then I'll make sure you have the answer of 36 ml per hour. Okay. If you ever do a Google search for the heparin protocol, you'll see that there's 15 steps. Steps 11 through 15 are after the patient's been on the protocol for 6 hours. They get reevaluated. They reevaluate their PTT, and they look to see what time frame it falls into. Is it too low, too high? Meaning, are they bleeding still too much? Or are they clotting too quickly? So we want to intervene. And then so for this, it tells us we're going to increase by 2 units per kilogram per hour. The initial infusion was 18 units per kilogram per hour. And then the question says, what is the new rate for the infusion? And use the same initial weight. So if we're talking about the same initial weight, the 100 kilograms, this is what this is referencing. Okay, so, and I'll just add this here. And then go ahead and get an answer. Let me know what you get. And then I'll double check. Yes, I'll go over how I got the 36 ml, but go ahead and try the number 16 just to see if we get that. But I will go over how we got the 36. I will tell you, I got to 36 the same way I got to 14.6, right? Patient's weight in kilograms times 18. And then, but instead of doing the 250 over 25,000, I did 500 over 25,000. But I will go over that, yes. And then let me just verify because I didn't get my answer yet. Okay, good. All right, while some of you are still working on the new infusion, let me go back to how we got to the 36 ml. So remember, we're looking for milliliters per hour. So they tell us that. And even if they don't, if it says rate of infusion, you automatically want to think flow rate, and typically you're thinking milliliters per hour. The only reason you would ever think drops per hour, and that's the thing with heparin, because it'll tell you heparin drip. But if you watch how heparin is going into the patient, it is a drip. So it is dropping slow. It's just that it's not measured. You could still say we're giving them, 36 milliliters an hour. But think about how slow that is, right? How slow is that administering? It's going to be very, very slow. Keep in mind, like, what's a shot? A shot is, I think, 60 ml or 45 ml. It's 45 ml. So like a shot, like an alcoholic drink. How quickly can you put that down, right? In an instant, okay? But we're titrating this over a period of time, which is why you have this small number. So, all right. So looking at this, we're going to take the patient's weight first. So the patient in this scenario weighs 100 kilograms. And it's telling me to start an infusion at 18 units per kilogram per hour. So that's really the same as what we saw in the first scenario, okay? But in this scenario, they changed up our available. they changed up the available, and they said this time now it's in a 500 mil bag, but it's still 25,000 units, which means it's more dilute. So 25,000 units, 500 milliliters. So we eliminate kilograms, we eliminate units, and we're left with milliliters per hour, which is what we're looking for. Multiply across the top, 100 times 18 times 500, divide by the bottom, 25,000, and that will give you 36 mil per hour. So for the next question, we're using the same information, but now it's telling us to increase the rate of the infusion. So they're already on, and if they're already on 18 units per kilogram per hour, but now they want you to step it up. Okay. So what would be, if you haven't solved this yet, because I've only received 2 answers so far, what would be the new units per kilogram per hour if I increase it by 2 units per kilogram per hour? What would be the new number? Good. Yeah. 20. Right. So we're increasing the flow at this point, and we've stepped it up by 2 units per kilogram per hour. So instead of multiplying the 100K or 100 kilograms by 18, now we're going to be multiplying the 100 kilograms by 20. So let's write that out just in case you want to see it. 100 kilograms. Now it originally was 18 units, but now we've increased it. And then the same thing, we want to convert units per hour to milliliters per hour. So that's where we plug in what we have available, which is the heparin infusion, or the heparin IV 500 mil bag with 25,000 units. They're together, right? And then when you do the math on that, you just get, and then I always like to double check that I'm crossing out stuff. I get 40 mil per hour. Now, if you do this how I did it initially, where I take the patient's weight times 20 units per kilogram per hour, and then you you write that out, and then you get an answer. So like you'd get 2,000, then you do the times 500 divided by 25,000. That's perfectly fine. I always say there's no one way that's correct. I'm just showing you the dimensional analysis version, which I know a lot of students are not big fans of, but that way you can at least see where I am setting up and getting all these problems and how I'm arranging it. So the only thing that would be different for this problem is you would take 100 times 20 equals, and then whatever that number is, then you would multiply by the 500 over 25,000, and then you would get the same answer. What's important is do it your way. And as long as you're getting the same answer I'm getting, then we're both doing it the right way. Okay. All right. Let's try another one here. Let's try. Now this is just a different variation. It's telling you that we have 5,000 units IV push. We have available 10,000 units per milliliter. How many milliliters will you need to administer to achieve a 5,000 unit dose? So this is very much similar to, and I'm going to change this up. Let's make this a 2,500 unit IV push. Okay. So how many milliliters would you need to administer? And I'm just going to leave it at that. So it's a different type of question, but this is basically like a variation of a bolus dose question. And I apologize. I'm going to change I want to change this a little bit. I want to make it 25,000. Okay. So you're being told to push 25,000 units. The available is 10,000 units per milliliter. So how many milliliters would you administer to get to that 25,000? Yep. Yep. You got it. Good. So I'm going to stop marking all those, but yeah. And this, you're just doing, if you like to do ordered over available, what are you being ordered? 25,000 units. What do you have available? 10,000 units. And what's your quantity? Okay, so if you prefer your ordered over half, and then you would push 2.5 milliliters. Now let me ask you this. What if that was 2,500? If that was 2,500 and you divide it by the 10,000 units times the 1 milliliter, you're going to get 0.25 milliliters. Okay. This is your answer because it's a number less than 1. So when it's a number less than 1, you don't round it. You don't round that to 0.3. You leave it as to the hundredths place, the 0.25. Okay. So if you get a question like that, and you might, then that's how you would leave your answer. Don't change that answer to 0.3. You will be tempted to, but remember, if you go back to the blueprint, what do the rounding rules say? Numbers greater than 1 round to the nearest 10th. Numbers less than 1 round to the nearest 100th. All right, let's look at this one. Let's see if we can change this question up a little bit. Let's get rid of that. Where's it? 18. So heparin 20,000 units in 500 ml, infusing at 20 ml per hour. How many units per hour is heparin infusing? So let's make this, instead of 20 ml, let's just make this 50 ml per hour. Just change it up a little bit. This is a different type of question, but basically we're asking you to convert milliliters per hour to units per hour, basically going in the reverse. So this will be a challenge. Go ahead and try this one and see if you get the same answer I get. All right, so I've got a couple answers coming in. Hopefully you got 2,000 units per hour. If you didn't or just don't know where to start, let me help. So what I always say, like what this question is asking you to do is to convert milliliters per hour to units per hour. Okay. So I just need a way to convert milliliters to units. And I can do that with my IV bag. So I start off with patient's weight, or the patient's weight, 50 milliliters per hour. And before I do anything else, I always say, okay, well, what am I trying to get rid of? Trying to get rid of milliliters. And what am I trying to convert it to? Units. Same thing we've been doing when we converted units per hour to milliliters per hour. We're just doing it in reverse now. And then I look at my IV solution. It says 20,000 units, 500 ml. So I'm going to put the units with the units, ml with the ml. And then I'm going to get 2,000 units. Oh, yeah, 2,000 units per hour. I don't know if you'll see a question like that, but I know you'll likely see it on like ATI. So it's a good one to know how to solve. All right. Now there should be a question on here about the nitroglycerin drip. So let me just find that real quick. Here we go. All right. So, Maddie did a really good job of giving you some alternative scenarios. So let's start off with this one here. Now this is going to be very similar with nitroglycerin. Sometimes it's going to be a weight-based problem, which is why you'll see it where like it'll say like a patient's weight in kilograms or pounds and you have to convert it. Sometimes it'll go right to the order and the available, and that's just a matter of converting things like minutes to hours, micrograms to milligrams, and things like that. So let's change this up a little bit. Let's make this, let's say we're going to start the patient on what's to say 50 micrograms per minute. The nitroglycerin is mixed, and I'll leave this alone, 25 milligrams in a 250 ml bottle. And then it tells you the concentration, and it even tells you 100 micrograms per milliliter. Now I'm going to double check this. So if you're ever wondering how to kind of do that, what I would do is I would convert milligrams to micrograms. So I'm 25. So 1 milligram is 1,000 micrograms. So that means it's 25,000 micrograms divided by 250 gives me 100. So this concentration is correct. Okay. So you can kind of ignore this, the 25 milligrams and 250 ml, because it gives us also on the bottle the concentration in micrograms. So all we need to do is convert micrograms to milliliters and then minutes to hours. So if you are told to infuse at 50 micrograms per minute, what would your answer be if you converted it to milliliters per hour? And then just go ahead and put that into the chat. And those of you that have already answered 25, go ahead and do 26, where I've changed it to 60 micrograms per minute, and they want you to convert that to milliliters per hour. So go ahead and try that one, and then I'm going to explain 25 here. So if you're wondering what you would get for 25, your answer would be 30 mil per hour. How did I get that? I start off with the so first of all, this is what I'm trying to do. I'm trying to convert micrograms per minute to ml per hour. Okay. So what is my micrograms per minute? 50 micrograms per minute. I know that I can convert micrograms to milliliters by using the concentration here. So 100 micrograms, 1 milliliter. But I also need to make sure I'm converting minutes to hours. And that's a common thing that gets missed when you do some of these things. When you do that, then you'll get to 30 milliliters per hour. If you got 0.5 milliliters per hour, you actually were at 0.5 milliliters per minute. You got to make sure you convert ml per hour. All right, so I got to check my answer for 26. You got it. All right, and so for 26, when you do this one, you should get 18 milliliters per hour. Again, if you get stuck and you're like, well, how do we get to that? Remember, the first question is, what are we doing? We're converting micrograms per minute to milliliters per hour. So that's what these nitroglycerin titration questions are. You're really just doing conversions. So anytime you hear like heparin weight-based protocol, what are we doing? Conversions. Nitroglycerin drip titration, what are we doing? Conversions. So this is where if you have said, I never need to learn dimensional analysis, it's, that's for the birds. This is where it really comes in handy because it helps to simplify at least having a strategy. Okay. Now, if you're getting these answers and you're not using dimensional analysis, great. Whatever you're doing, those of you that are giving me answers and you're getting them right, keep doing that. If you are doing dimensional analysis, then that makes sense to me. And there are ways to kind of circumvent that, but I always like to show it to you that way. You at least have a strategy in case you ever get stuck. And if I can get you to watch this recording, pause it, write out the steps, hit play, make sure you wrote out the steps correct, hit pause, rewind, go back to the beginning of the problem and see how I'm setting these up. It gives you a strategy. But if you have a different strategy and you're getting the same answers, don't change what you're doing. Okay. Your instincts are correct. So keep leaning into those. All right. So if you're stuck on this one, you're going to take the 60 micrograms per minute. Now, with dimensional analysis, you get to choose kind of your adventure, as it were, and you can do a variety of things. But there's a lot of converting in this particular question. What I'm going to do is I'm going to convert, first and foremost, minutes to hours. That way I can get that out of the way. Okay. Now I can hit equals at that point, and then I would have 360, I think that's right. So 60 times 60, 3,600 micrograms per hour. Okay. So why don't I just do that real quick, just so you can kind of see alternative ways to do this. So 3,600 micrograms per hour. Okay. Then what I'm going to do is I cannot do math if I have micrograms here and milligrams here. I have to, they both have to be the same units. So I either need to convert milligrams to micrograms or convert micrograms to milligrams. Since I'm already here and I'm writing this out, I'm just going to go ahead and convert this micrograms to milligrams. So 1,000, 1 milligram. And then that's going to give me 3.6 milligrams. Shoot. Sorry. I hate when that happens. 3.6 milligrams per hour. Then I can go ahead and convert milligrams per hour to milliliters per hour using the available. So 50 milligrams, 250 ml, and that's where you get 18. Now, when I plug this into my calculator to confirm the answers that were coming in, what I did is I took 60 times 60, then I divided by 50,000 times 250, and that's how I got to 18. So if you're like, that's how I did it, perfect. You did that perfectly correct. So like I said, there's no one way to get to the same answer. Or I mean, yeah, I mean, there's multiple ways to get to the correct answer. Just make sure whatever answer you're doing is correct. So, all right. So we have like 5 minutes left. Is there any other questions that you wanted to at least see? I think I'll have time for like one more. But is there another question type? I wanted to hyper focus on the heparin stuff and the nitroglycerin stuff because that's completely new to you guys for this semester. But if there's any other questions, just either type in a chat, unmute. Let me see here. Oh, okay. Yeah. So let's see if there's an example of going for insulin. Yeah, here. So for this one, basically we're doing the same thing, right? So we're converting units per hour to milliliters per hour. The only thing that's different is instead of heparin, it's insulin. So you're going to set it up the exact same way. So let's say this was, I'm going to change this up a little bit. Let's say this was 250 units. And let's say this was at 25 units per hour. So I'm just changing some things up here. Okay. So what this is asking you to do is convert, just like we've been doing, units per hour to milliliters per hour. So you're going to follow the same thing. The only thing that's different is the drug in question. Okay. So if I'm, go ahead and try this one, number 24, that I changed the number, and I'll change the number on this too, just so when you come back to it, you can kind of see and try something different. So let's say. So go ahead and try 24 and let me know what you get. And then I'm going to double check. So for this one, you should get 50 milliliters per hour. All right. So like I said earlier, if you go back to and you look at this review and you go to the key, all the key is, or some of the key is going to be correct, but anything that I wrote on, I changed, I changed the question. I changed the question type and answer. If you are going through this and you want to kind of challenge yourself, just change a variable in the question. If you do that, copy and paste it, email it to me, and I can confirm that you got that answer correct. If you just want some further verification, or if you do like a handful of them, just you got to give me time to answer those. If you're sending to me like Sunday night, 10 p.m., I may not get to it until Tuesday. So I'm just letting you know that you want to give yourself a little bit of leeway, a little bit of time for that. So give me some time. But I have a little bit of time on Saturday that I'll be able to kind of look at some stuff for dosage calc. And so I can answer some questions. I may have a little bit of time on Sunday. It just depends on my daughter's dance schedule and whether or not I have access to Wi-Fi at her dance studio. So, all right. Okay, so I will post this video up later today. So I'm done with my reviews at around 3:30, and then that's when I'll close out of Zoom. It'll then get me the reviews, and then I'll have them up around that time. So, all right. Well, if I don't hear from you, good luck on your test. And if you have any questions, if for some reason you don't pass and you need to remediate, just know I'm here to help. But I think you guys, you've gone through this 2 semesters now. You got this. So just practice, rewatch the videos if you need to, repractice. Even if you're practicing the same question 100 times, practice the process of setting it up. And then the only thing that's really going to change is the variables. So good luck on your test. And I'll talk to you soon.